Okay, welcome back. This is the second video on polar roses. This time we'll be doing r equals sine of 3 theta. And since 3 is odd, we expect that the theory is correct, which we'll see it is, to get 3 petals, and we get them in 180. So if you set up your calculator to do a graph and you do it for 360, it will appear to you that the second half of that, nothing's happening. And what the machine is really doing is it's graphing the curve twice. So you can check that. You go back and you check your theta max to 180, and you'll see your curve. Okay, one correction. The last video with r equals sine of 2 theta, I said it went through the origin 8 times. That's not correct. You can count the number of times it goes through, but it's not 8. Okay, it'll be corrected on the black on the worksheet or on the notes I put up on Blackboard. Okay, so let's take a look at this one. It should go a little more quickly since we know what the process is. All right, once again, I have set up a chart, and at this point, you're probably realizing that the numbers are a little bit different. In the last example, r equals sine of 2 theta, I went up by 45, and hopefully you realize that if you double the 45, that gives you 90, and that's how we got into the quadrantal angles. Here, what's happening is I'm going up by intervals of 30 degrees. So I'm going to go theta is 0 to 30, 30 to 60, 60 to 90, so forth and so on. And then 3 theta, if this is from 0 to 30, it's going from 0 to 90. If this is 30 to 60, it's going from 90 to 180, so forth and so on. And again, we create our, not really a table of values, but a chart of what's going on here. When theta goes from, well, in next case, it's really 3 theta here. But when the sine curve goes from 0 to 90, the height goes from 0 to 1. From 90 to 180, the height goes from 1 to 0. From 180 to 270, the height goes from 0 to -1. So it's going through negative values, and we're going to see that flip. When it goes from 270 to 360, again, it's increasing, but it's still going through negative values. So we'll see the flip. This is our chart. Okay, so let's use that to make a sketch. Okay, from 0 to 30. Now, you got to think a little bit now. 45 was right in the smack in the middle. However, if we're going from 0 to 30, we're only looking at this piece of quadrant 1. Okay, so we go from 0 to 30. 3 theta is going from 0 to 90. The sine curve is going from 0 to 1. So we're going to start here because the sine of 0, of course, is 0. And we get to here. And again, we're going to keep track of the orientation, or the direction the path is traversed, by putting a little arrowhead here. This is the first part of our journey. And then from 30 to 60, right to here, we can see the 3 theta is going from 90 to 180, and the sine value is going from 1 down to 0. So here's the 1, and it's shrinking down to 0. Okay. So hopefully we can see at this point that this point has coordinates 1, comma 30 degrees. And again, this is the r, this is the theta. Okay, and this is the second leg of our path, the second leg of our journey. We're coming out of here, all right, roughly at a 60-degree angle. And at this point, now we're going to be looking from 30, from theta is 60 to 90. But as you can tell, we're going to be going through negative values. So this is going to be reflected down here. Okay, so what that means is that we're going to be going from third leg of our journey. We'll be going from 0 to -1. So in other words, when we get here, these are going to be negative values. They'll be reflected down here. Okay, So we get to this point, and that point would have coordinates -1, 90 degrees, right? Because we're at 90, we're looking at triple that of 270. You got a value of -1 for the sine. Okay, and now as we go from theta is 90 to 120, okay, 3 theta is going from 270 to 360 through negative values. All right, so it's going through negative values. So therefore, if we're here from 90 to 120, we're going to be in this region, negative values, because it reflects back. All right, so if I can go back here, this is the fourth leg of our journey. And now to go from theta is 120 to 150. Notice I marked these out in thirds. So each interval here is 30 degrees. So this will be 90, this is 120, this is 150. So from 120 to 150, okay, theta is 120 to 150. Tripling these in 3 theta is from 360 to 450. Now it's positive values, so I am not going to flip because these are positive values. Okay, so what will be happening here then is as we go from here to here, okay, we're not flipping. This is the fifth leg of our journey, and indicate the direction or the orientation for arrowhead. And the sixth leg of our journey, we're going from 150 to 180, and tripling, that's from 450 to 600. Is that right? Yeah, 450. Oh, sorry, this should be 540. Haha. Okay, so let's change that. 540. All right, because triple 180 is 540. So to go from 450 to 540, the R value is decreasing from 1 to 0. Okay, so this is the sixth and final leg of our journey. And the point here, of course, would be 1 comma 150. So that would be our third pedal. Okay, so and we can see we have a complete polar rose. We have 3 pedals, and we did it in 180 degrees. So that's the meaning of this. When n is odd, that's the number of pedals you get, and you get that in 300 and 180 degrees. If we graph this to 360, what would happen is it would go around a second time. Okay, and it looked like the calculator is doing nothing. All it's doing is just plotting right on top of the earlier points. Okay, so we can count here how many times it goes through the origin, or the pole really. So let's see, so that's 1, 2, 3, 4. Okay, so it goes through the pole 4 times, and that should be set up like that on Blackboard. Okay, so I hope this is helpful to you, and you can definitely find the notes on Blackboard with this complete chart, and away we go. Okay, the next topic we'll cover is polar form of complex numbers, which leads into de Moivre's theorem, which is very interesting. And again, on the self-directed graphing exercises, I suggest that you do them and you verify what I'm saying. Let the calculator do the work to see if you can predict what the curve will look like. Okay, thank you.